It is insoluble in water but soluble in carbon disulfide and toluene. Effect of heat. When sulfur is heated in limited amount of air, it melts at a temperature between 113 degrees centigrade and 119 degrees centigrade into an amber colored liquid. The color darkens as the temperature increases. At about 160 degrees centigrade, the liquid starts to turn viscous, reaching its maximum viscosity at 200 degrees centigrade. On further heating, it begins to flow again and boils to give off a light brown sulfur vapor at its boiling point of 444 degrees centigrade. When this vapor is condensed on a cool surface, a fine powder which forms a floral pattern is obtained. This is known as flowers of sulfur. Molten sulfur is often poured into tubular molds to form rolled sulfur. Chemical properties. With excess air, it burns when heated with a bright blue flame to form sulfur dioxide. That is, sulfur burning in oxygen to give sulfur dioxide. Combination reactions. Sulfur combines directly with metals and nonmetals when heated in air. Hydrogen sulfide. It is frequently found in volcanic gases and as a major component of gases got from the decay of organic matter containing sulfur. Laboratory preparation. Hydrogen sulfide is prepared by the action of dilute acids on metallic sulfide. Example: zinc sulfide reacting with hydrochloric acid gives zinc chloride and hydrogen sulfide. Iron sulfide reacting with sulfuric acid gives iron sulfate and hydrogen sulfide. Precautions. The apparatus is set up in a fume cupboard because hydrogen sulfide is poisonous. The gas should be collected over warm water, not cold water, because it is very soluble in cold water. Collection of the gas. If the gas is required dry, it is passed through a U-tube containing fused calcium chloride and collected by downward delivery, since it is denser than air. Note: concentrated sulfuric acid cannot be used to dry the gas because it oxidizes it to sulfur. Physical properties. It is a colorless gas with a repulsive smell like that of rotten egg. It is a very poisonous gas and so should be handled in a fume cupboard. It is fairly soluble in water, producing a weakly acidic solution. It burns with a pale blue flame. Chemical properties. 1. As a precipitating agent. Hydrogen sulfide reacts with metallic salts to form insoluble sulfide, which is colored. When bubbled with salts of such metals, the insoluble sulfides are precipitated. Example: hydrogen sulfide reacting with copper sulfate gives copper sulfide and sulfuric acid. Zinc sulfate reacts with hydrogen sulfide to produce zinc sulfide and sulfuric acid. Reaction with oxygen. Hydrogen sulfide does not support combustion, but it burns in plentiful supply of air with a bright blue flame to produce sulfur dioxide. In limited supply of oxygen, a yellow deposit of sulfur may be formed. That is, hydrogen sulfide reacting with oxygen gives sulfur dioxide and water. When excess, hydrogen sulfide reacts with oxygen to give sulfur and water. As a reducing agent. Hydrogen sulfide is a very strong reducing agent. It is therefore used in qualitative analysis to test for oxidizing agents. During this redox process, the hydrogen sulfide is usually oxidized to sulfur. It decolorizes the purple color of acidified potassium permanganate. The color change is due to the reduction of the purple permanganate ion to manganese 2+ ion. With acidified potassium dichromate, it changes its orange color of the chromate ion to green. It reduces the halogens to their respective halides. Example, chlorine reacting with hydrogen sulfide gives hydrogen chloride and sulfur. Iodine reacting with hydrogen sulfide gives hydrogen iodide and sulfur. It reduces the brownish yellow solution of iron 3 chloride to a green solution of iron 2 chloride. In the process, it is oxidized to sulfur. Hydrogen sulfide is a stronger reducing agent than sulfur dioxide. Therefore, it reduces it to sulfur in the presence of moisture. Test for hydrogen sulfide. If the unknown gas has a repulsive smell like that of rotten egg, then it is probably hydrogen sulfide. A confirmatory test is by reacting the gas with aqueous lead nitrate. If the gas is hydrogen sulfide, a black precipitate will be formed. Uses of hydrogen sulfide. Hydrogen sulfide can be used in the analysis of ores and metals. The presence of a certain metal can be indicated by the color of its sulfide. Example, silver sulfide, lead sulfide, copper sulfide, iron sulfide are all black. Zinc sulfide is white. Tin sulfide is yellow.